Let us learn few more important statements that are useful when we are accessing linked lists. So I'll remove these things and take some examples and I will show you. Let us take this example. I have few nodes, a linked list is there, and pointer P is pointing on some node. And this node is having a pointer to the next node. And also I have one pointer Q. Let us see some syntaxes and understand their meaning. See, if I say Q assign P, what does it mean? Q assign P means whatever is there in P, that has to be stored in Q also. So whatever is there in P has to be stored in Q also. So Q will have the address 200. So this 200 is there, so it will also get 200, and Q will be pointing on the same node. This node is 200. So if I write P assign Q means Q will also point on the same node. This is the meaning. So two pointers pointing on the same node. Now let us look at next syntax. If I say Q assign P is next, what does it mean? Inside Q we want to store P is next. So what is P is next? This is P, its address is 200. Its next is here, that is 210. So this is 210, we want to save it in Q. So Q will be getting the value 210. So this is 210. So now where Q is pointing? Q is pointing on next node. So if you read it, let Q point on the next node of P. Let Q point on the next node of P. So P is next assign Q. So on next node of P, Q will be pointing. Then one more statement. If I say P assign P is next, like we have already seen that let Q point on next node of P. So here, what is the meaning of this? Let P point on next node of P. P point on next node of P means P is 200 right now. P is next. P is next means this one. What is the value there? 210. So that 210, where it should be stored? It should be stored in P. So it means this value should be taken and kept inside P. So this becomes 210. So when that P is having 210 means P is no more pointing on this node, P is pointing on this node because this address node is 210. So this statement has made P move to next node. P has moved on to the next node. This is very useful statement, very much useful statement in linked list. Like if I have a pointer P that was pointing on some node, moving pointer to the next node, this is the code. P assign P is next. So P is next is stored again in P. So this 210 is stored in P. So P is pointing on next node. We will see few more statements. I'll just change the example. Then we will see few more statements on this one. Next, I have two examples. Pointer P not pointing anywhere. It is null. Address is 0. And the second one, pointer P is pointing on some node in a linked list. How to make P as null? We can write here 0, it will be null, or else we can write capital NULL for null. So either you say 0 or null. So both are same thing only. Now let us see these two examples. If pointer P is not pointing on any node, then it will have a value 0, address 0, that is null. If it is pointing on some node, then it will have some valid address. And that value will not be 0, it is non-zero. And if you know, in C++ programming, 0 means false and any other non-zero value is true. So if pointer P is not pointing on any node, then it is 0. 0 means it is false. And when it is pointing on some node, it will have non-zero value. That means it is true. Now let us see the conditions to check if a pointer P is pointing on some node or not. So if I write first condition, if P is equal to null. If I say P is equal to null. So out of these two cases, in which case this condition will be true? P is equal to null. In this case, it will be true. So this means this will be true if pointer P is not pointing on any node. It's not pointing anywhere. And second condition, if I write If P is equal to 0, then out of these two cases, which condition will be true? This will be true, that P is having 0, means P is not pointing on any node. If I write not P, in which case this condition will be true? P is 0. 0 means false. But not of 0 is true. Again, this condition is true in this case. So these are the three methods of checking if a pointer is not pointing on any node or not pointing anywhere. So yes, if pointer is null, then these three conditions are there. We can check if it is null or not. If it is null, then these conditions will be true. Now how to check these conditions? I have to just write inverse of these conditions. So I can say if P is not equal to null. Here P is null, but here not equal to null. Yes, this will be true. So this condition will be true if pointer P is pointing on some node of a linked list. Then another way of writing this one is P is not equal to 0. So just inverse of this condition. And even I can write if P, just P. So what is the value of P? 200. If 200, so 200 is true or false? So 200 means true. So if P means true, true means pointer is pointing on some node in a linked list. So these are few important conditions. Now I have one more conditions to show. So for that I'll remove this. Now one more condition. I want to know whether after node P, let us call this as node P because P is pointing here, there is some more node or not, or P is the last node. So let us see this. If P caps next, that is P is next, this one, is equals to null or 0. If this is 0, then this condition will be true. It means this is not pointing on any node. So if this is not pointing on any node, means this is the last node in a linked list. If suppose it's not pointing anywhere, then that will be last node in a linked list. Another condition, if P is next is not equal to null. So then when this condition will be true, if there is some address present here, means after this also there is some node or not. Usually we require to check this type of conditions. So these are a few important statements and conditions that are commonly used while working with linked list. So that's all in this video.